a techie like you guys, so I want to make sure you guys have what you need and use your resources. Look at all these things. You guys are like awesome. Never forget to write. Yes. Agree. I'm just moving your stuff. Okay. So dimensional analysis, we have units and a chemical, so you're noting like the identity. If you're talking about sodium chloride, if you're talking about sulfur, you're talking about whatever, good. You learned what a mole was. Yay! That was kind of not the exact goal of last night's homework, but a mole is a quantity that we use in chemistry because we talk about really, 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 really tiny particles. And instead of saying, oh yeah, I counted 6.022 times 10 to the 23rd of that, you're like, I counted a mole of them. And nobody's ever counted a mole of things because that's like way too big of a number. But if your mom said, hey, Kendall, go to the grocery store and need a dozen bananas, he doesn't have to go, oh my gosh, what's a dozen, right? You just know a dozen is what? 12, right? So now in chemistry, you just know a mole means 6.022 times 10 to the 23rd things, right? So we're going to use that more and more. We're going to use it a little bit more today. But what you also probably noticed, with maybe if I can move this, dimensional analysis is a way of converting. So we can convert a lot of things in our head, but sometimes we're going to have 3, 4, 5 different conversions between something, and we can't do that in our head. So if I said, you know, 1 kilometer is how many meters, you're going to tell me what? 1 kilometer is how many meters? 1,000 meters, right? So you converted that in your head. Some other conversions we have are not just like, you know, 1,000 over 1 or 1 over 1,000. They're like 4.16 over 1. Well, I don't know. I mean, I can do 1,001 with that, but different numbers you can't. So we're going to learn how stoichiometry, which is chemistry math, and dimensional analysis, we're going to learn they're basically the same thing. Dimensional analysis is just a way of writing things and canceling units. So you have to write a unit pretty much all the time. Okay? So if you're still posting, keep posting, because I can go through and see, oh, yes, this is perfect. All ratios are equal to 1. So if I said a dozen bananas and 12 bananas, they're the same thing, right? So whenever you do something like this, 12 bananas and 1 dozen, and they're the same thing, that's essentially saying 1 over 1, meaning all ratios are equal to 1. Same thing like you just told me, 1 mole is 6.022 times 10 to the 23rd things, or particles, or whatever. They're the same thing. 1 over 1 is 1. So we're really not changing the quantity, we're just changing the way it looks. We're calling it something else. So keep posting if you're posting. Let's quick questions on reading guide 1 and 2. Reading guide 1 and 2. You guys have any questions? I don't think there's too much new stuff except for the chemical physical changes. And you have some definitions on that on chapter 2. Speak now. Yeah, thank you.
What's the difference between an intensive property and extensive property?
Intensive and extensive. This one depends on amount present. The extensive, it depends on the amount present. So, like, if I had a bunch of something, it's going to weigh mass more than a little bit of something. So the amount matters. But if I had an ocean full of water, what's the density of water? 1 what? Gram per milliliter or centimeter cubed, right? So I can have an ocean full of water, and the density is what? 1 gram per milliliter. Or you can have, you know, this much water, and the density is still 1, right? So it doesn't matter how much is present. It's an intrinsic property. It's a part of it. It's like, it doesn't matter how much you have. It's always the same. So independent of amount. Okay? All right, another question? Yeah? Yeah, thank you.
Why is alchemy considered negative?
Because they were given no credit for the logic behind a lot of times there was no method behind the magic, right? They have rules how they were doing things because it wasn't creditable. So there was no research. There wasn't peer reviews. There weren't any research-based strategies. So anything like that would work. Yeah?
You have a stable.
Stable? I do. That's not relevant right now. I'll get you one if you need it later, okay? Just dog ear if you need to. Okay. Pass the reading guides? Yeah? Reading guides 1 and 2, pull them up. Okay. It's okay. No, I'll just dog ear it. I'll staple it when I grade it. Usually I do. And please pull out your lecture notes that I gave you guys, we did have them. We're going to do the rest of today. Thank you, people at the front, for being so responsive. I'm going to take that up in your portfolio check. Yeah, good question. So, someone just asked me, are you taking up the 6 bullet points right now? No, I'm not. Hold on to it right now. You can take notes on the 6 bullet points. Oh, wait. Hold on. Thanks. The 6 bullet points of notes you took last night, keep those. You can write your notes on them. I'm going to be taking that up in your portfolio check. So sometimes I'll wait and take up something in portfolio check if I feel it's valuable for you to keep right now. Reading guides, I'll pass back as soon as I can. Other than that, we're going to start taking some notes here. So keep those at your desk. So we are math savvy people. Who likes math? You're math savvy? Okay. Get your notes out. Get your lecture notes out. And if you don't have a calculator, you can use your phone for a little while, and I'll pass out some calculators in a second. Okay, game plan. Quick review of simple math, like solving for x, rearranging variables, just to make sure we're on the same page. And if it's you got it, please let me know. And then we're going to move on to dimensional analysis for real. All right, so this is a gas law. We're going to use a law later, this law later. And it stands, these variables mean different things: pressure, volume, temperature, and some other stuff. Now, if I wanted you to solve for R, somebody tell me how you would do that. You don't have to write this down if you don't want to. Raise your hand. How'd you solve for R? Thank you.
Wouldn't you just like take the n and the t to the other side by dividing it?
By dividing by n and t. Good. Divide by n and t on this side. They cancel because they're on top and bottom of the fraction. So note, if something's the same on the top of a fraction and the bottom fraction, they cancel, leaving r over here and pv over nt on this side. So simple, right? Thumbs up, you got that. You can solve. Cool. What if I want to solve for p1 on this one? Go for it.
Multiply the right side by t1.
Okay, so you're going to multiply both sides by t1, right? So you multiply, I know it cancels on this side, and t1's over here, so canceling on this side leaves us v1 p1 equals v2 p2, I'm going to write that a little higher so it looks like it's in the numerator, t1 over t2, and then?
And you divide that by v1.
Right, then you divide this side by v1 so that it cancels, and v1 just stays in the denominator over here because it's divided. So, in the end, p1 is equal to v2 p2 t1 over t2 v1. So, you can do two steps like that. You can do cross multiplication division. I think it's called bow tie. You know what I'm talking about? Or floppy dot chop, something. You guys do something just like that? Okay. So, everybody calls it something else, but it's the same thing. So, I just want to make sure you're reviewing your previous math skills as we go through this. If I wanted to solve for x right here, what would I be doing first? Anybody? What do I do with the parentheses? Whenever you see two things that are similar on the same side, you combine like terms, right? First. So combine these two x's for me. So 2x cubed equals 180. Good. And this square, or this x, this 2 is just hanging out. There's not really a reason for it there. You're going to divide by it. So then you get x cubed is equal to 90. And then you cube root to solve for x. Okay, so little math skills we just want to be aware of. Okay, let's keep up. Let's talk about dimensional analysis. Okay? Oh, you can't even see dimensional analysis. Dimensional analysis. Okay. We have two names for this. Let me get SpongeBob out of the way. Maybe. Bye, SpongeBob. Okay. Two names for it. Factor label method and dimensional analysis. On your sheet, right? Nope, here it is. Okay. So we use conversion factors. Conversion factors. Factors sounds like fractions, kind of. And that's what we're going to be really using, fractions the whole time, okay? Numerators on top of a fraction, denominators on the bottom of a fraction. So in our previous example, we said 12 bananas. This is one that you're familiar with, is equal to 1 dozen. And you can write a conversion factor as a fraction because they are the same, they're equivalencies. They're the same thing. So you can then write them on top of each other in a specific way though. So if I said I need 10 dozen bananas, if I start you off with 10 dozen, how many bananas is that? 120. You just did that in your head because you know how to multiply by 12, right? But the way you're really doing it in your head, and you may not just be aware of it, is I'm going to write it. Let me just give myself some more space here. I'm going to write it down here. 10 dozen times the equivalency of 12 bananas over 1 dozen. So why am I writing it 12 over 1, not 1 over 12? Yeah.
Because you want the bananas as your unit that you
Right. I want to be. My question was how many bananas is that? My real question was asking the unit of bananas. I'm asking for that specific unit in the end. So I need bananas to be the last unit remaining. So the dozen here cancels with the dozen here because they're a unit that's on the numerator of the whole shebang and the denominator of the whole shebang. So the only unit left is banana because it didn't get canceled. So that's what you could do in your head. But what if I said how many dozens is 10 bananas? Then what would you do? Okay, so I need to flip this fraction, right? I need dozen to be on top. So I'm starting off differently. I'm starting off with 10 bananas, and I said how many dozens is that, right? It's not even a full dozen. We know that just because it's 10 and not 12. But some other things we're going to be less familiar with, so this is an easier example to start off with. So then you said, okay, I'm starting you off with 10 bananas. 1 dozen goes on top. 12 bananas goes on bottom. And why is the 12 bananas going on the bottom? Just to cancel the bananas on this side, on numerator, denominator, leaving you with the desired unit of what? Dozens. So it's 10 over 12. That's 5 over 6, which is like 83? I was going to say like 87.5, but I can't. 0.83, I'm going with you. Help me out, yeah. 8 what? 0.83. 83, thank you. So that's the final answer there. Okay, I'm not going to do sig figs right there. Dozen. So that's all dimensional analysis is. It's just canceling units using equivalencies. So the fractions that are made are called fraction units, or they're fractional units. Things like grams per milliliter, where we've seen that. Density. We're going to learn about something called grams per mole. And all of these things, and this is not like JK, this is joules per Kelvin. Okay, joules per Kelvin. Joules is a unit of energy we'll talk about. Did you define joules last night? No, Joules, joules, not like joules. So that's just a unit of energy we'll get to later. So we're going to use all of these things. With this, though, we're also going to go back to our metric stuff to implement that within some of the problems. So you're going to get started? Yeah? Preview? Done? Let's do some math problems up here. I'll give you guys another second. Maybe? Okay. I don't think I skipped stage. Okay. So sometimes you're going to be given a lot of information in a problem. You've got to pick out the important stuff, and you've got to pick out the conversion factors. What does a conversion factor usually look like? It's got a top and a bottom, so it looks like a fraction. Okay, conversion factors look like fractions. So CF is a conversion factor, and it looks like a fraction, or it should have a fractional unit. So when I'm looking at this question, or I'm looking at this given, the density is given as 2.7 grams per centimeter cubed. This is that conversion factor. We will use this as a fraction. Just know that the 2.7 grams is going to be the numerator. What number goes with centimeters? Huh? Take a guess. 1. I saw 1. People were mouthing it to me. You can say it out loud. Because there's nothing there, but there still is something there. It's a 1. Because anything over 1 is still whatever it is. So that's the fraction. Okay, so looking at this question, we have 40.0 centimeters cubed of aluminum, and it's saying how many grams is that? So what's our real question? Is grams. And our starting point is our given. It's the first number given to us. It's a singleton number. It's not a fraction. Okay? So I'm trying to show you how to get started. Anytime you have a word problem, because you'll have a couple of them, you're like, I don't know where to start. So you're going to start with the given. It's a pure fact. It's a data point, and that's it, no fraction. And you're going to start with this. You know that in the end, you want what unit on top? Grams, because the question is asking for grams. So if I want grams on top, and I have this conversion factor, do I take it like this and write it, or do I take it and flip it? Write it as is, because the grams are already on top, so don't have to do a darn thing. 2.7 grams of aluminum is equivalent to 1 centimeter cubed of aluminum, leaving us with centimeters cubed and centimeters cubed, same numerator and denominator, so only that unit will cancel. Grams is the only one left, okay? And then in your calculator, 40.0 times 2.7. 108, exactly? Okay, is this our final answer? Okay, what am I doing then? Sig figs. How many sig figs should I have? Limiting one, right? So this one right here is our starting point with 3 sig figs. This one is our conversion factor, which is a measurement actually, and it is 2 sig figs. So how many sig figs? 2. Round this. 110. There you go. All right. So some people have a hard time with this at first because you've probably never done math like this, but this is just a new method of math, and we're just going to get the hang of it first. Okay. So next question: 40 grams of aluminum requires how much space? What am I asking for here? Volume space, right? So it's talking about centimeters cubed or milliliters, because volume can be either. And our designation of the conversion factor, sorry, look at all these nice tools that pop up. Our conversion factor has centimeters cubed units, so we're going to go with that. So what am I starting with in this one? My starting point was my fact. 40 grams of aluminum, right? Times, what's the conversion factor for this one? Say again? So centimeters cubed, so 1 centimeter cubed goes on top over what? 2.7 grams. I know I just covered that up. That was that conversion factor I had written up there. All we did was flip it, so the centimeters cubed is on top, because grams on top and grams on bottom now need to be able to cancel. So always just double check that your units cancel, leaving you with what you were looking for. Yep. And then 40 divided by 2.7, what is that? Calculate. 6. I'm going to stop in there, okay. Centimeters cubed, round 6 figs. 15, yes, good. Okay, so that's a good point. I heard somebody say 1 sig fig. This right here, this density here, it was designated as 2.7 grams per centimeter cubed, right? That 1 is something we kind of put there as a placeholder. We say, like, there's a number there, it's a 1. It's not used for sig figs. It's this one right here. That's our 2 sig fig one that's going to be limiting us. And we'll keep practicing that, so you kind of get the hang of it too. All right, let's do a couple more. And if you calculate with me, you stay engaged a little bit, because sometimes after lunch you're like, I'm so sleepy. Okay, so I have a lot of information about water. Ooh, ah. Now you know the heat of fusion of water. Fusion means to melt. So water requires 40.65 kilojoules, a unit of energy. It requires that much energy to melt a full mole, a full huge number of water molecules. We kind of all knew the density of water already. This is at room temperature, and then we know a couple more things here. All of these things are what? They're fractional, so they are conversion factors. You don't have to know these. I will give these things to you. They'll be in a problem. They'll look like a fraction like that, or they might say water, 1 mole of water is equal to 18.02 grams. So it might say it out versus have a fractional unit in it. So you just kind of have to watch. So if I start you off with this right here, and I'm asking for how many moles, which of those conversion factors is actually relevant for this problem? Which one? The molar mass one. It's the only one that has both units. The grams and the moles. The grams and the moles. So you choose conversion factors based off what's given to you and what's asked of you. So in this one, again, starting off with 40 grams of water, what do I multiply by? What fraction? What goes on top this time? Right, 1 There's a 1 there, right? So 1 mole goes on top, and O2. Somebody calculate. Shout it out. What is it? 2.2. Thank you. 19 moles. Good. So again, you see your grams cancel here and here. Moles left. Yep. Good. This is not correct all the way though. Round for me. 2.20. Good. Because this is 3 sig figs. This is 4 sig figs. 2 or 3 sig figs wins. Okay. Let's do a 2-step one. Who's feeling kind of
How do you know which unit is on
the whichever one has the is related to the question. So the question is how many moles. So you choose that particularly. You make it work out so that the question that you want in the end or the unit you want in the end is on top. Because in the end, this, whatever you started with, will cancel with something you placed in the denominator. I am videoing too, so you guys can always look at this later too. Okay, so if I had to choose for this one, milliliters and molecules, did you see anything with both of those in it? Milliliters and molecules? No, so this one's not going to be a direct conversion, it's going to be a 2-step conversion, okay? So let's look at a 2-step process before we actually do the math. You start with milliliters. You want to get to molecules. Starting with milliliters, what conversion factor has milliliters in it? Just the density. So you really have no choice. Like, that is the one you got to use first. So I'm going to write this one in a different color right here. 80.4 milliliters times what, with the appropriate way you have to write your fraction. What do you want to cancel is what I'm asking. What unit do you want to cancel? Milliliters. So I'm going to take this one and write it how right here. Be confident. You got this? Yeah, 0.9994 grams on top. 1 milliliter goes on bottom because I need to get rid of the milliliters. I don't care about milliliters. I want to get rid of them. Now, I don't really want the gram, though, but it's a stepping stone to get me to my next part. So the milliliters are now canceling. Now, my goal is to I'm starting kind of new. I have grams. I want to get to my question. Which conversion factor is now relevant? Is there anything with grams and molecules in it? The molar mass has grams and moles in it. Like I said, a mole, just MOL, mole is like a dozen. It's a big, huge number. Molecules are like, H2O. There we go. That's a molecule. Moles and molecules are not the same thing. That's a big thing people get wrong all the time. So molecule is a thing. Mole is a big, huge number. So there's nothing with both grams and molecules in it. So now I have to find the one with grams in it. That's important to get me to my next stepping stone. So you said molar mass, I'm guessing, right? This one has grams in it, moles in it. Now, but once I get to moles, where am I going? This one, right? So that is equivalency to the last one. Good. So I need to take this one right here, and what am I writing on bottom? Yeah, I need to put the grams on bottom. And that 18.02 sticks like glue to the gram, okay? Do not separate them. They go together. And then the 1 mole is going on top. So good. Grams and grams cancel. And my final step is to get rid of moles by putting it where? What's going on the bottom? 1 mole, right? This is a 1 mole. If there's not a number with it, it's a 1. So 1 mole and 6.02 times 10 to the 23rd molecules. MOLE apostrophe C is molecule for me. Okay, so you'll see that sometimes. Okay, so now how do you calculate moles and moles cancel? Okay, how do you calculate this one? In your calculator, 80.4 times 0.9994, and you can either multiply by parentheses 1 divided by 18.02, or you could like kind of stop your calculation and divide by 18.02. Then multiply whatever that is by 6.022 times 10 to the 23rd. Shout it out when you get it. Not every at once. Does any of these numbers start with a 2? Thank you, Zach. exactly.
They gave 2.684337376 I'm assuming the E is the same as X one.
Right. E is times 10 to the 24 molecules. Okay, and I went a couple numbers in. How many sig figs should this one have? 3, good. 3 sig figs on this one, 4 on that one, right? 4 on this one, 3 on this one. So I'm sticking with 3. So this needs to be what? 2.68 times 10 to the 24th. Don't forget the size of it. It's still very large. A lot of molecules. Tons of molecules. So on a scale of 1 to 10, how do you feel about dimensional analysis right now? 10 means like I'm rocking it. 1's like, what in the heck are we still talking about? Throw them up. It's okay. I just need to see. Okay. Thank you for nobody's looking me off. Okay. All right. Let's do like 2 more then. Let's do 2 more like this, and I'm gonna let you guys practice a different set. All right. So using kilojoules. Kilojoules is just a larger version of a joule, right? It's like a kilometer, kilogram. We want to get to grams. So is there anything with kilojoules and grams together in these conversion factors? No. So tell me our thoughts. We have to start with kilojoules. What's going to be our next one? Or what unit has to be in the denominator of our next one? What has to be in the denominator of the next one, of this coming one? Kilojoules, right? Is there anything with kilojoules in it? Okay, so we have this. All right, so let's see if that's our next step. And before, I'm not going to write anything yet. I'm just going to kind of walk through first. We have kilojoules. We need to cancel kilojoules. So we can use this one, but do we have to write it as is? Do we flip it? We flip because we need to get the kilojoules in the denominator. So now we're stuck with moles on top. We're stuck with moles on top. Remember, we're going to grams. So then what would we use next?
Can Sally tell when it comes to the front office
Right
at
now?
the end of class?
Thank you.
Thank you.
Remember. Okay. So we have moles on top. We need to cancel moles now. What's our next conversion factor? Do you see anything with moles in it and our desired unit?
Yes.
Molar mass, right? You see it. All right, so now let's piece it together. Sometimes it's nice to look at it first and then kind of put the puzzle together. We are starting with our 64.2 kilojoules. We need to cancel kilojoules. It must go in the denominator to cancel. We see that kilojoules is paired with the mole, so we're going to put the mole on top. 1 goes with the mole, 40, thank you, 6.5 goes here, because that number sticks with kilojoules. That allows us to cancel kilojoules and kilojoules. Then you stop and breathe. You're like, okay, gotta cancel mole now, because nobody cares about moles, we care about grams. Mole goes on bottom, because it must cancel on top and bottom. And then this particular one had grams with it, which is a good thing, because we need grams. The 18.02 sticks with gram, and the mole has just a lonely 1 with it. Moles are then going to cancel because they're on top of the numerator and the bottom in the denominator. So then you get, in your calculator, 64.2 divided by 40.65 times 18.02. So anything that's in the denominator you must divide by. 459, round. 28.5, good. Because this has how many sig figs? 3, so this one is, everything else has 4 up here. This right here needs to be rounded, and those people still a little struggling with rounding. You look and you say you need 3 sig figs, you start from the left, you move over. 1, 2, 3. You have to record 28.4, but you got to double check before you record your final, make sure that doesn't influence it, but it does. The 5 does influence the 4 to round up, so this is our final. All right, you guys want to do one more, yes or no? Yes? Okay, let's do one more here. And then we'll do some metric ones. Sorry, my conversion factors are way up here, so I got to keep scrolling up and down. This one's a little easier, actually, okay? So what is my starting number for this one? 500, right? So 500.0 grams. Is there a way for me to get from grams to my desired unit of moles? From grams to moles. How many steps? Just 1. Yes, okay, so 18 grams per mole is that conversion factor. So how do I write it here? Gram per mole, or, right, 1 mole on top, good, and 18.02 grams on the bottom, because you just have to finagle it so that Your grams are on top and then on bottom, and then you go back and you double check, yay, I have the unit I wanted on the top. And then that is, I have no idea, 746, sorry, there we go. So 746, and then round that to what? 7, yeah, sorry, that 6 does round that 4 up, so 75. Okay, so let's go to a different version. Let's go to metric, because these are all new units you've never heard of. But the reason I do this first is to prove to you that you really don't have to know, what the units are. You just need to see the same unit here and the same unit here for cancellation. So I could have puppy dogs and dinosaurs up here, and if I said 4 dogs is equal to 1 dinosaur, that's a conversion factor, because I told it to you, right? It doesn't have to make sense. So I threw some stuff at you that you may not have known to prove that you can do this without actually knowing the units. So you'll see a couple different units throughout, but we're going to hit metric again because we talked about them yesterday. And I'm only going to do like 1 or 2 from each of these, and this is what's on your printed sheet. Okay? And you'll see some like this in a little while tonight. So at the top of your paper, write down your number line. King. Tell me more. Henry. What happened to him? Oh my gosh, he died! Ow! Die what? Thinking. Tablet. Bill. ... Micro. ... Nano. ... Pico. That one doesn't fit the storyline. There's mega in the front. Okay. So write that down on the top of your paper. You're going to use it. Let's do a quick conversion from... Let's go number 3 right here. Convert 84345.6 micrometers to meters. Okay? These are things that you could easily do decimal swoops for. But I want you to do it dimensional analysis way so you can practice that skill. So I'm going to write this right here. My given is this, 84345.6 micrometers. Dimensional analysis. What do I want in the end? What's the question? What do I want to convert to? Meters. So what has to go on top? Meters. I want the meter. What do I not want? Micrometer or the micrometer, however you want to say it, okay? I know this is what my unit scheme is going to look like because I say, okay, I got to get rid of this guy so I can get to the meter. Then you're going to take this and you're considering your number line. Of the units, which is the bigger unit? Meter, right? Because it's at where on the number line?
Base.
It's at base, thank you. People think M is meter. M is milli. Okay, so it's at base. Base is how many away from micro? How many zeros away? Including the dots. Remember, the dots are zeros. You weren't here yesterday. So those are zeros. So it's 10 to the 6 different. Okay, so here's how you write it. You choose the bigger one. Choose the bigger unit. Make it a 1. 1 meter is equal to how many little bitty micrometers? 1, 0, 0, 0, 0, 0, 0. Ain't nobody got time to write that many zeros. 10 to the 6 meters in micrometers. Okay, so that means there are 1 million micrometers in 1 big meter. Does that scale make sense? Because those are smaller and that's a bigger one. Okay, so in your calculator, put 8.4 or 84,345.6 divided by 10 to the 6. And if you're using exponents in your calculator, sometimes you want to double check and just put parentheses around this, just so the exponent stays where it's supposed to and doesn't apply like at the end to the final answer. Tell me what you get. You should get 8.4. Okay, I'll write your way and then I'll write it my way. 0.084346. Yeah? Yeah? Okay, and that's meters. I'm sorry, I'm off the side of the board here. That's meters. Or you could write it as 8.43456 times 10 to the negative 1. Okay? Scientific notation. Same answer though. But I know that you can do this by decimal swoops because if you're dividing by 10 to the 6, what happens to the decimal? What happens to the decimal? It moves left. 1, 2, 3, 4, 5, 6. There you go. I know you can do that, but I need you to prove to me you can do it both ways. right, let's look. That's a metric one with a single unit using the number line. Let's look at one that's using number line but a little fractional unit going on here. Let's look at number 5. Convert 88 meters per second to centimeters per second. So starting with what? It's my given. And I want you to write it like a fraction. This, I know it's written kind of as a fraction, but it's next to each other. Write it as numerator, denominator. So 88 meters per second. That's our given. And like I said, I know most of the time givens don't have fractions, but sometimes they do, like when you have rates and densities like that. Okay, now from this unit to this unit, what's really the only thing that's changing? Just the length, right? The centimeters and meters. So what is the only unit I need to play with? It's not seconds, it's just meters. So I need to take this one and cancel it. So how do I cancel it? Put on the bottom. What unit do I want on top? Centimeters. All right, and this is the rest of it. Stop, breathe. Look at your number line. Which is the bigger unit? Meter, say it's a 1. How many little centimeters are in one big meter? How do you know 100? Because it's what? Good, it's 2 away. So if here's meter, it's 1, 2, it's 2 zeros away. Centi is 2 zeros away from base. So this is 100 or 10 to the second, however you wish to write it. So there's 100 little centimeters in one big meter. And that logically makes sense. So then the units that cancel are meters here, leaving us with centimeters per second, because we never touch the second. So we still have centimeters per second at the end. But now the math is just taking 88 times 100 to get what? 8,800. Okay. You guys do number 6 on your paper. I'll let you get halfway through it and I'll see where you are. The more engaged you stay, the better you'll feel about your homework tonight. So you're starting by writing your given. A light, okay. What do you first want to consider that's changing? The numerator or the denominator? What's easier for you? You're gonna play with the numerator first, so we can cancel it out? Because you'll notice that the grams goes to kilograms, right? So let's ignore that there's even this milliliter thing here, and start by trying to cancel grams. So I need to put grams on bottom. What do I want to go to? Kilograms, good. And then stop and breathe. Which is the larger unit? Kilograms, it gets at what? 1. How many little grams are in a kilogram? 1,000, because it's 3 zeros away from kilo. So the way you look at that, I'm going to scroll right back up to the number line. There we go. Scroll right there. And you have kilo, and you have the base here at grams. The way I like to always do it is I put the 1, like you said, 1 goes to the kilogram. The 1 goes under the prefix, that's the larger one, and you write zeros until you get to your next unit. So that's how you say 1,000. It's 1,000 times greater, so there's 1,000 little grams in 1 kilogram. So grams and grams are done. Now, we've got kilograms on top. Do not touch them. I need to get this milliliter thing gone. What do I need there instead? Liters, because the question is asking for liters. So now I need to take, and it's okay that we're going across the ocean here, across this little guy in the middle. We need to take the milliliter and we need to put it over here on top, because you can cancel things even if they're far away from each other. It's just top and bottom. It's just numerator denominator. And what unit has to go in the denominator? liter, because that's what the question's asking for, is liter. Okay? So now that you have this, you have your units all in the right spots, so you just have to add the numbers now. Of these two units, which is bigger? Liter, so the liter gets the 1. What's the milliliter number? 1,000 again, because at the liter, the 1 goes with the liter. Liter is a base unit, so grams, meters, and liters are all base. So there's a 1 there, and they're going to milli, so boom, 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 1,000. 1,000 milliliters in 1 liter. You kind of knew that already. Okay, so what unit cancels on this last one here? Millis, right? So the milliliters here, and this milliliter way over here, it's just top and bottom. It cancels. What is left? Kilograms over liters. Kilograms over liters. That's what we wanted, people. Yes. What do you notice about this problem? The thousands are on top and bottom too, so they negate each other. Woo, we did all that math. The answer is still the same. Okay. That one was harder. That one's you know, you gotta look at multiple places and piece them together. Synchronous spaces. Get up, stand up, take a break, go see somebody, say hey. Like, don't leave my room, but talk to people in here. Take a break for a second, and I'll choose our next problems. Yeah. Let's roll back just in case somebody needs this.
When you know when to do like the same thing, do it all on the other
Let me go back. Metric always has a 1. Every single time, because you know I'm saying. So everyone's metric. I will not know. You use that. Alright, go back to your desk. Alright, go to the next one, and then I think that I answered this question, so thank you. I need to know sometimes what I'm not explaining well. Shush. Thank you. This one right here, it says start with the base given, and it says go to base unit. Again, what are the 3 base units? Hold on, stop. Not milli. Milli is a prefix. It's not a unit. Meters, liters, and grams. So I am not going to require you to stop the base unit and move on. Let's do 1 in 1 step, because a lot of these are like, you got to go 2 steps on this. No, you can just go straight. Let's go from this decimeters to, what's the big M? Megameters. Okay. So 88000 decimeters I need to cancel what unit? Decimeters. Nobody likes decimeters. We like who? Megameters, okay. Which is the bigger unit on your number line, which you've written out. Mega, so he gets the 1. On your number line that you have written out. Henry, die, fine, drinking, chocolate, milk, micro, and so forth. Okay. So how many zeros away is mega from deci? 7? I believe you and stuff, but let me check. 1, 0, 0, 0, 0, 0, 0, 0. 7. Good. So nobody's got time to write 7 zeros. 10 to the 7. So in your calculator, you do it, and you get your answer to be 8.8 times 10 to the negative 2. Hold on, let me double check that. Because if you divide by 7, your decimal goes 1, 2, 3, 4, 5, 6, 7. My bad, negative 1. Megameters. So you'll get scientific notation most likely in your calculator. But again, you're working with the number line specifically on this problem. Okay. Notice I did not have to stop at meter and then go to megameter. I just went all the way through, passed through the base right here. All right, let's do a more difficult one. Can I go forward? Is that cool? Negative 1. What? Was I right? Oh yeah. 1, 2, 3, 4, 5, 6. Okay. I did that. See if you guys are watching. Okay. Oh, my bad. Yeah.
Yeah. Why did you have to change it to sign? Why don't you just do 0.08 for the last one? We're cool together.
You cannot like it and do your own thing. I don't care. Either way, it works for you. Yeah. Okay. My calculator reports everything in scientific notation, so I have to like it. Okay. Let's do a cubed one. These are harder. Put a star on this because this is the one probably if you get this so pretty well started, this is the one you're gonna want to start. Okay, this one just takes one extra step. Okay, so write this one down. Convert. Oh, and note to self. Whenever you have a unit that is a single unit that is cubed and you're still converting it to a similar version of it but is also cubed, the conversion factor you are writing is going to be cubed or squared, whatever the case is. So the conversion factor itself is going to get its own little cubed exponent to it. So that's what I'm going to demonstrate right here. So write down your given. And then I'm going to cover up I know you can still see it on my hand, but I'm covering up the cube. And if I were just going, if the cubes were not there, and I was just going from meters to centimeters, what unit goes on top? What goes on bottom? Meters. Because I'm going from meters, let's cancel here. The centimeter unit must go on top. Again, which is the bigger unit? Meter. How many little centimeters are in a meter? 100, and you just know that, or you can count over on your number line. So now can I get my setup there? And then I'm going to say, okay, I know for reals there are cubes here. So the conversion factor I have must be cubed, meaning this 100 is cubed. What's 100 cubed? 1 times 10 to the 6, 10 to the 6. Yeah. Okay. 1 million. Thank you. Okay. What's 1 cubed? Hurry. 1. Okay. So you're going to take 800.4 times 1 million and get 800 billion or something like that, right? I mean, 8 billion. 8 billion. 800 billion. Something. I'm going to go scientific notation. So 8.004 times 10 to the 8. You can try that in your calculator. Centimeters cubed because the centimeters are also cubed and the meters are also cubed. And I'll show you my cancellation in just a second. Yeah.
Do you have to record 0, 0?
Yes, good point. Because it is a 4. It's an ugly 4. It's part of the sig fig rule because there are in this number 4 sig figs. So I must record 4 sig figs. So thank you, Sally, for reminding me. You saw that. she had a good question. For all this metric stuff we're doing, we're ignoring this one and this one sig fig number and our measurement and this one sig fig measurement, because guess what? Every single metric conversion has a 1 in it, right? So if you consider sig figs on this, every single answer you do would have to be recorded to what sig figs? 1, which is not true, okay? So whenever we're doing metric, don't look at the sig figs on that particular conversion factor. Just look at your given, say 4 sig figs, record 4 sig figs. So just because this is a tool we're going to use to kind of lead into bigger, fatter dimensional analysis. Yeah.
How did you get the 8.004?
Whenever you like literally type in your calculator 800.4 times 10 to the 100 cubed, it will come out to be, let's see here, 8, you said 8, 8 billion for, hold on, 1, 2, 3, I think it's 80, right? Hold on. 8. Okay, I thought it was 800 billion when I said it the first time. There we go. 800 billion. 400 million. Oh my goodness. Zeros are everywhere. Okay, 400 billion, like that. Yes, okay. So when you get that number in your calculator, million, yeah, thanks. Okay, when you get that number in your calculator, that's for 1, too many zeros to write, as you can see. I'm struggling. You need to then look at 4 sig figs, count from the left, and move 4 sig figs over. 1, 2, 3, 4. Those are the only ones you're allowed to write, and everything else must be zeros. You can write it like that, and that is still correct because that has 4 sig figs in it. This is just a little bit easier to write, I think. But, your opinion can be different. You can have opinions. Okay? So the meters cubed here cancels with the meters cubed here because this cubed is distributed, this cubed is distributed, da 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 da. So 3 meters cubed and 3 meters cubed cancel, leaving you with 3 centimeters cubed. Take down the wall there. You were still counting those zeros. Let's look at number 2. And just you guys do that. Set it up and we'll finish it. This one. Yeah. Okay, you ignored the squared for a minute, yeah? Just ignore it, pretend it's not there. I'll scratch it out like I did earlier. Ignoring the squared. What did you put on top? What unit? Kilometers. And what unit did you put on bottom? Meters. Bigger unit? Kilometer. Smaller unit gets a what? 1,000, because from K to M it was 3 zeros different, so 1,000. And then you're like, oh, forgot, it's squared. So what do? Square the whole shebang, and you get meters squared and these meters squared because it's going to distribute in here, 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 and here. So now I'm going to write that one. I just put on the outside just so it's not redundant. Now that you have meters squared on the given, it will cancel with meters squared in the denominator. But what is the final answer? It should be 88.46 divided by 10 to the 6th, which is 8.846. Thank you. Yes. Kilometers squared. Okay. I think I've killed this enough. I think. let me look and make sure there's not like one more word problem I want to do with you. Because if you look on the very bottom of your paper, your lecture notes, there's 10 through 15. Those are the ones I want you to be able to practice. Because I've done all the ones where it's just like, here's a given, here's a question. These have like the conversion factors embedded in it. So we have about 40 minutes left, okay? My goal is to leave you with 20 minutes for homework. And yesterday our lab, I thought I would have 20 minutes for homework. We didn't get to it. So my goal is to do that today. I already did some conversions where you converted the numerator and then the denominator. So I'll give you like 2 to do on your own, and you can ask me questions. So I'll give you, this is on your paper, yes? Yes. Circle right now the 2 that I want you to do. We'll do number 2 and number, no, I don't remember, no, foot per yard, there's 3 feet per yard. Okay. If you don't know, foot per yard, 1 yard is 3 feet. I know we're not supposed to be using that particular system, but we are. And you guys know how many dollars in a cents. Okay, that's our conversion factor there. So put a star on those 2. I want you to do those 2. And then I want you to start the word problems 10 through 15. Okay? And you can write that on a separate sheet of paper probably, because you're probably not going to, well, you might have room at the bottom. You just do what you got to do. And then I want you to start on problem set 3B in class, so you can ask me questions, okay? And then my motivation. It's going to be a lot of work, but we're in this together, okay? Air 5. Thank you. Thank you. Okay. So, 2 problems on the multiple step ones, 5 word problems. I will be here moving around, ask each other for help, asking for help. The calculator there right behind you now, if your phone is going to not be a good choice for you right now. Okay? Especially if you get distracted like on Snapchat and stuff. You might get day. Let me stop this video.